there, children. Gandalf the Graphing Wizard here talking to you about point-slope form. Now here's a question. What do you call a hobbit who joins a fraternity? YOLO Swaggins!
Okay, first thing we're going to do is review slope-intercept form. That's y equals mx plus b, where m represents your slope, which is your rate of change, your rise over your run, and b is your y-intercept, where your graph crosses the y-axis. Now remember, x is going to be your independent variable, and y is going to represent your dependent variable. Those are always going to stay x and y. The m and the b are going to be what you plug in specific numbers for. Now, point slope form is y minus y sub 1 is equal to m times the quantity x minus x sub 1. And in this, x is your independent variable, y is your dependent variable. Those are going to stay x and y. You're going to plug in numbers for y sub 1, m, and x sub 1. Now, m is still your slope. In each of the forms that we talk about in this chapter, m is going to represent your slope, your rise over run. Your x sub 1 and your y sub 1 represent a point on the given line. So if you know one of the points on the line and you know the slope of that line, you can always create the point slope form of the equation of that line.
What did Boromir tell Led Zeppelin when they wanted to go to Mordor? One does not simply rock into Mordor. Example time.
Example 1 says write an equation in point-slope form of the line that passes through the given point and with the given slope m. So here we have a point and we have a slope. Anytime you're given a point and a slope, you want to start by putting it in point-slope form. So point-slope form requires point and a slope. Here we have our x sub 1, we have our y sub 1, and we have our m. So in point-slope form, y minus y sub 1 is equal to m times the quantity x minus x sub 1. We're going to plug in 3 for x sub 1, negative 4 for y sub 1, and then 6 for m. Now again, notice how I plug in this negative 4. I put parentheses around the negative 4 because what's going to happen is this negative sign is going to combine with this negative sign. If I'm going to basically multiply negative 1 times this negative 4 and it becomes positive 4. And now this is the point slope form of our equation of the line that passes through this point with this slope. Part B, doing the same thing. We have a point and we have a slope. So this is going to be our x sub 1, this is going to be our y sub 1. Again, highly recommend under your given point, write x sub 1 and y sub 1. That way you know exactly where to plug those things in to your given point slope form. Now our point slope form looks like this. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. So I'm going to plug in 7 for y sub 1. I'm going to plug in 1/2 for m, and I'm going to plug in negative 1 for x sub 1. Remember, whenever I'm plugging in an x coordinate or a y coordinate that is negative, I'm going to put parentheses around it. Why do I do that? Because that's going to show you I'm going to take this negative and multiply it to this negative 1. This negative is the same as negative 1 times our negative 1, which is going to be positive 1. That's why it becomes x plus 1 in our parentheses down here.
What did Frodo say when he saw the trees dancing? Now that's entertainment! The trees are called heads. You try!
Okay, doing the same thing. Here we have our x sub 1 and our y sub 1, and we have our m. Make sure you label it. That way you know exactly where to plug it in to point slope form, which is y minus y sub 1 is equal to m times the quantity x minus x sub 1. 2.5 is going to go in for my x sub 1. 1.3, our y sub 1 is going to go in here, and 7 is going to go in for m right here. Is there anything to simplify? Are there any negatives that need to become positives? No. So this is the final answer. We have our point slope form of our equation. And remember, this is the equation of the line that passes through this point with this given slope. Here, part B, we're doing the same thing. This is our x sub 1, this is our y sub 1, this is our slope. So now, point slope form, y minus y sub 1 is equal to m times the quantity x minus x sub 1, meaning I'm going to take negative 3/4, plug it in for x sub 1, take negative 6/7, plug it in for y sub 1, and take negative 5 and plug it in for m. Remember, whenever I'm plugging in an x coordinate or a y coordinate that is negative, I'm going to put parentheses around it. Why do I do that? Because it's going to remind me that since this is y minus our y sub 1, I actually have to multiply this negative to this negative 6/7 and make it positive 6/7. Same thing here. This negative sign is the same thing as negative 1 times negative 3/4, which becomes positive 3/4. And now you have the point slope form of the equation of the line that passes through this point with this given slope. Example 2 says write an equation in point slope form of the line that passes through the given points. I know that in order to write an equation in point slope form, I need a point and I need a slope. A point, that's easy. I just pick either one of these. It doesn't matter which one you pick. I'm going to pick this first one. This is going to be my x sub 1. This is going to be my y sub 1. Next, what is my slope? Well, can't I find the slope between two given points? Didn't I learn a formula for that? Yeah, you learned the slope formula, which is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, I have an x sub 1 and a y sub 1. I guess that would make this x sub 2 comma y sub 2. So now I plug those in to my slope formula. Remember, I highly recommend you write this down on your sheet of paper. That way you know exactly what to plug into the slope formula and where to plug it in. So 2 is going to go in for y sub 2. 7 is going to go in for y sub 1. 1 is going to go in for x sub 2. And 5 is going to go in for x sub 1. Now I simplify this. What's 2 minus 7? That's going to be negative 5. And what's 1 minus 5? That's going to be negative 4. Now what's negative 5 over negative 4? Negatives cancel out and you get positive 5/4. So now we have our slope and we have a point. So we can plug that into point slope form. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. So let's plug those in. 5 is going to go in for my x sub 1. 7 is going to go in for my y sub 1. And then 5/4 is going to go in for my m, my slope. Now, can I simplify this any further? Is there any negatives here? Nope. So looks like we're good. That is the point slope form of the equation on the line that passes through these 2 points. Now, anytime you're given 2 points like this and asked to write an equation in point slope form, there's 2 different answers you can get. This is one of our answers. We could also do the exact same thing, except this time when we have our point and our slope, we could make the other point, 1 comma 2, our x sub 1 and our y sub 1. So if that is our point, what would be our slope then? Well, if that's our x sub 1 and y sub 1, then this would be x sub 2 comma y sub 2, and we're going to plug those in. So y sub 2, 7 is going to go in here, 2 is going to go in for y sub 1, 5 is going to go in for x sub 2, and 1 is going to go in for x sub 1. What's 7 minus 2? That's going to be 5. What's 5 minus 1? That's going to be 4. Oh look, our slopes are exactly the same, and they should be. Next, I plug my point and my slope into point slope form. So 1 is going to go in for x sub 1, 2 is going to go in for y sub 1, and 5/4 is going to go in for my slope m. Are there any negatives here that we need to simplify? No, so this is the point slope form of the equation on the line that passes through these 2 points. Now here's the weird thing. These 2 equations look different, but they are the exact same line. If you were to graph these on a graph, they would be the exact same line. And if you were to simplify them down into slope-intercept form, they would be the exact same equation. And we'll show you that when we start converting from point slope form to slope-intercept.
Why did the little child at the wedding follow Frodo to Mordor? 'Cause he was the ring bearer. You try.
Okay, doing the same thing here. Again, in order to write an equation of a line in point slope form, I need a point and a slope. A point, that's easy. I just pick either one of these. It doesn't matter which one you pick. I'm going to pick this first one. This is going to be my x sub 1. This is going to be my y sub 1. Now, what's my slope? Well, in order to figure out slope, I need x sub 1 and a y sub 1 and an x sub 2 and a y sub 2. So this would be my x sub 2 and y sub 2. Now I can plug those in to the given slope formula in their corresponding spot. What's negative 1 minus 4? That's going to be negative 5. And what's 2 minus negative 3, that's the same thing as 2 plus 3, which is going to be 5. What's negative 5 over 5? That's negative 1. So my slope is going to be negative 1. Now I use point slope form. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. I'm going to plug in negative 3 for my x sub 1, plug in 4 for my y sub 1, and plug in negative 1 for my m, my slope. Now, is there anything I can simplify here? Yes, this minus negative 3 is the same thing as negative 1 times negative 3, which is going to be positive 3, so plus 3. And now I have the point slope form of the equation on the line that passes through these 2 points. Or I could have done it the other way. I could have made my point 2 comma negative 1. If that's my x sub 1 and y sub 1, then my slope should be the exact same. Okay, it shouldn't matter which point you pick to be x sub 1 and y sub 1 and which one you pick to be x sub 2 and y sub 2. So let's plug those in. Let's make sure that's true. What's 4 minus negative 1? That's the same thing as 4 plus 1. It's going to be 5. And then negative 3 minus 2 is going to be negative 5. Now what's 5 over negative 5? That's negative 1. These match up as they should. Now, the only thing that's different is the point. So I'm going to plug in 2 for my x sub 1, negative 1 for my y sub 1, and negative 1 for my m, my slope. Is there anything I can simplify? Yeah, this minus negative 1, I can make y plus 1. And now I have the point slope form of the equation on the line that passes through these 2 points. Again, these 2 equations look different, but they are the exact same line. If you were to graph these on a graph, they would be the exact same line. And if you were to simplify them down into slope-intercept form, they would be the exact same equation. And we'll show you that coming up now. Example 3, write an equation in point-slope form of the line that passes through the given points. Then write the equation in slope-intercept form. So we have 2 points. In order to write an equation in point-slope form, I need a point and I need a slope. So what's my point? Let's pick the first one. X sub 1, Y sub 1. There we go. We got it. So that's going to be our point. And now what's our slope? Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. So this would be my X sub 2 and Y sub 2. And now we plug these into their corresponding spots. 3 goes in for Y sub 2, 4 goes in for Y sub 1, 8 goes in for X sub 2, and 6 goes in for X sub 1. Now what's 3 minus 4? That's going to be negative 1, and 8 minus 6 is going to be 2. So our slope of this line that passes through these 2 points is negative 1/2. Now I'm going to plug that into point slope form here. Negative 1/2 goes in for my m, and then 6 is going to go for my x sub 1, 4 goes in for my y sub 1. Anything to simplify? Nope. So this is my point slope form of my equation. Next, I need to write this in slope intercept form. What is slope intercept form? That's y equals mx plus b. So I need to get y by itself on this side of the equation. So I'm going to eventually add 4 to both sides, right? But I also need to get rid of these parentheses over here. Well, how do I do that? Let's distribute this slope. Let's distribute this negative 1/2. So what's negative 1/2 times x? That's negative 1/2 x. What's negative 1/2 times negative 6? Well, negative 6 is the same thing as negative 6 over 1. So we multiply the numerators together and denominators together, and you get positive 6 over 2, which simplifies to 3. Now all I have to do to get it in slope intercept form, I need to get rid of this negative 4. So to get y by itself, I add 4 to both sides. That way these cancel out, just like they're supposed to, and I get y is equal to negative 1/2 x, and then 3 plus 4 gives you 7. Or what we could have done is we could have started with x sub 1 and y sub 1 as our 8, 3. If we start with our point as 8, 3 instead of 6, 4, how does this change the problem? Well, we have m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is going to be our x sub 2 and y sub 2. We plug in 4 for y sub 2, 3 for our y sub 1. We plug in 6 for our x sub 2 and 8 for our x sub 1. We then simplify. 4 minus 3 gives you 1. 6 minus 8 gives you negative 2. So we get a slope of negative 1/2, just like we were supposed to. Next, we plug that into point slope form. So the 8 goes in for x sub 1, the 3 goes in for y sub 1, then negative 1/2 goes in for our m. Anything to simplify? No. So we have the point slope form of our equation. Now a couple things have to happen in order to get this into slope intercept form to get y equals mx plus b. I need to distribute this negative 1/2, and then I need to add 3 to both sides. So let's first distribute the negative 1/2. What I'm going to do is I'm going to take this negative 1/2, multiply it to the x. Negative 1/2 times x gives you negative 1/2 x, and then negative 1/2 I'm going to distribute to the negative 8. How do I multiply negative 1/2 and negative 8? Well, negative 8 is the same thing as negative 8 over 1. So that I multiply the numerators together, denominators together, and since it's a negative times a negative, it becomes a positive. So it's positive 8 over 2, which simplifies to 4. Now, again, I need to get y by itself. It's got to be y equals mx plus b, so I add 3 to both sides. That way these cancel out, and I get y is equal to negative 1/2 x plus 7. Wait, look over here. Y is equal to negative 1/2 x plus 7. Oh my god, they're the same. I was trying to tell you that these 2 point slope forms, they are different, but they are the exact same line. So if I were to graph these on the coordinate plane, they would be the exact same line. And what proves that is the slope intercept form of each of these point slope forms is the exact same.
Why couldn't Gandalf ever stop smoking his pipe? Because he had a bad hobbit! You try!
Okay, we're doing the same thing here. In order to put it into point slope form, we need a point and we need a slope. So what's our point? Sure, we'll pick this to be our x sub 1 and our y sub 1. So that's going to be our point. Now what's our slope going to be? Well, slope, remember, is calculated y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And since we're given 2 points, we have to use this slope formula. So this is going to be our x sub 2 and our y sub 2. Remember, I highly recommend writing that under each point. That way you know exactly what to plug in where. Now when I do that, what's 1 minus 4? That's going to be negative 3. And what's negative 1 minus 1 is the same thing as negative 1 plus negative 1, which is negative 2. Since they're both negative, I simplify that, make it positive, and it becomes positive 3 over 2. Next, we plug that into point slope form. So we plug in each of those to their corresponding spot. Any negatives to simplify? Nope. So we're good. This is going to be our point slope form of the equational line that passes through these 2 points. It says then write it in slope intercept form. In order to do that, what I have to do is I need to get y by itself. It has to be y equals mx plus b. So I'm going to distribute this 3/2 to the x and to the negative 1. 3/2 times x is just going to be 3/2 x, and 3/2 times negative 1 is going to be negative 3/2. Now it needs to be y equals mx plus b, so I need this minus 4 to go to the other side. How do I do that? I add 4 to both sides. That way these cancel out. And how do I add these together? Negative 3/2 plus 4. Well, I need them to have the same denominator, a common denominator. Well, this is 4 over 1, so I'd have to multiply the numerator and denominator by 2, and it'd be 8 over 2, right? Adding 4 is the same thing as adding 8 over 2. Now I can add these together. Negative 3 halves plus 8 halves is going to be the same thing as 8 minus 3 in our numerator, which is going to be 5 over 2. Remember, the denominator stays the same. Now I have my slope-intercept form of the equation of line that passes through these points. So if I were to graph each of these on a coordinate plane, it would give you the exact same graph. Or what I could have done is I could have chosen the other point to be my x sub 1 and y sub 1. And if I do that, then I need to again calculate the slope, but that should be the same. Let's do that. Make this x sub 2 and y sub 2. So when I plug those into the slope formula in their corresponding spots, I simplify. 4 minus 1 gives you 3. 1 minus negative 1 is going to be positive 2. So now I have my slope, and yes, that checks out. They're the exact same, as they should be. So now I plug this in for the slope, my m. I plug in negative 1 for my x sub 1 and 1 for my y sub 1. Now, is there anything to simplify here? Yes. Minus a negative becomes plus a positive, we said, and this is x plus 1. Now I have my point slope form, and it is different than this one. The slopes are the same as they should be, but the point is different. And that's okay, right? Because a line has an infinite amount of points that it goes through. So you can choose a different point. The only thing is, if I put this in slope-intercept form, it's going to be the exact same as this. And let's show you why. If I distribute 3 halves to the x, I get 3 halves x. If I distribute the 3 halves to the 1, I get 3 halves. Now I add 1 to both sides to cancel out this minus 1 and get y by itself. And I get y is equal to 3 halves x plus 3 halves plus 1. Now how do I add 3 halves and 1? Well, 1 is the same thing as 1 over 1. And since they need a common denominator, I just make it 2 over 2. That way they have the same denominator. 2 over 2 is the same as 1. Now I can add these together. What's 3 plus 2? That's going to be 5. So 5 halves is going to be my y-intercept. And look at that. The slope-intercept form of each of these point slope forms is the exact same because the equation of the line going through these 2 points should be the exact same in slope-intercept form. And all of these, when you graph them on a coordinate plane, they're the exact same line. Now example 4 says graph each equation. So here we have our equation of our line in point slope form. Anytime it gives you in point slope form, graph it out of point slope form. It's super easy. Here's how we do this. Well, point slope form is y minus y sub 1 is equal to m times the quantity x minus x sub 1. And in this form, you see that our x sub 1 is going to be 1, our m is going to be 2, but oh, this is a plus. This is supposed to be a minus. So what does that mean? Well, it means our y sub 1 is actually negative 3. So our point then is going to be 1 comma negative 3, and our slope is going to be 2. So in order to graph out of point slope form, all you have to do is plot the point. What is our point? We just said it's x sub 1 comma y sub 1, which is 1 comma negative 3. So we go over 1 on our x-axis, down negative 3 on our y-axis, put a point. Now all we have to do to graph the rest of the line is use the slope. What is our slope? Well, remember, slope is m, which is rise over run. What's the rise over run? Well, this is 2. Remember, 2 is the same thing as 2 over 1, which means we're going to rise 2 and run 1, which means we're going to go up 2 and right 1. So from our starting point, the point that we had, 1 comma negative 3, we're going to go up 2 and then to the right 1. And then we put another point. We go up 2 and to the right 1. We put another point. We draw a line through those 3 points, and we have successfully graphed our equation out of point slope form.
What did Gollum change his name to once he learned Spanish? Smigel! Ha ha ha! You try.
Okay, doing the same thing here. Again, point slope form is y minus y sub 1 is equal to m times the quantity x minus x sub 1. So here, we can see that our m, look at this negative. What does that mean? That means our slope is going to be negative 1. But now you see each of these are plus signs. They're supposed to be minuses. What does that mean? That means that our y sub 1, instead of being 5, is actually going to be negative 5. And our x sub 1, instead of being 2, is actually going to be negative 2. Sweet. Now we know exactly what to do in order to graph this. We first plot our point. What's our point? Remember, our point is x sub 1 comma y sub 1. So that's negative 2 comma negative 5. So we go over negative 2 on our x-axis, down negative 5 on our y-axis, put a point. Next, we're going to use the slope to graph the rest of the line. So what is our slope? That's negative 1. And since slope has to be rise over run, this is negative 1 over 1. Our rise is negative. That means we go down 1. And then our run is positive 1. So we go to the right, positive 1. So we go down 1, right 1, put a point. Down 1, right 1, put a point. Draw a line through those 3 points, and you're done. Now the word problem says the relationship between degrees Fahrenheit and degrees Celsius is linear. When the temperature is 50 degrees Fahrenheit, it is 10 degrees Celsius. When the temperature is 77 degrees Fahrenheit, it is 25 degrees Celsius. Write an equation giving the Celsius temperature C in terms of the Fahrenheit temperature F. What is the Celsius temperature when it is 59 degrees Fahrenheit? Okay, word problem. So step 1, we're not scared. Step 2, what is this question asking us? It's asking to write an equation giving the Celsius temperature C in terms of the Fahrenheit temperature F, meaning that C, the Celsius temperature, is going to be your new dependent variable, your new Y, and F, the Fahrenheit temperature, is going to be your new independent variable, your new X. And we need to write an equation giving Celsius in terms of Fahrenheit. So C equals, and then something times or added to F. Next, it says, what is the Celsius temperature when it is 59 degrees Fahrenheit? So we'll use that first equation that we find to do this. So let's find that equation. How do we write an equation? Well, what are we given in the question? We're giving that when the temperature is 50 degrees Fahrenheit, it's 10 degrees Celsius. And when the temperature is 77 degrees Fahrenheit, it's 25 degrees Celsius. Well, if F is our new independent variable, our new X, and C is our new dependent variable, our new Y, then aren't we given a X and a Y and an X and a Y? So aren't those 2 points? Yeah. And anytime you're given 2 points and it asks for an equation, what you're going to do is find the point slope form of the equation of the line going through these 2 points. So let's find our point slope form. We need a point, we need a slope. So you can pick either one of these to be your point. I'm going to pick the first one. Why not? This is our x sub 1, this is our y sub 1. And remember, in this case, since f is our new x value and c is our new y value, that's why we have f sub 1 and c sub 1 instead of x sub 1 and y sub 1. So that's our new point. And then our slope, again, to find slope between 2 points, we need the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And again, c is our y, f is our x. So now what we do is we plug these in. We only have an f sub 1 and a c sub 1, so this is going to be our f sub 2 and c sub 2. So we plug those into their corresponding spots in the slope formula. What's 25 minus 10? That's going to be 15. And what's 77 minus 50? That's 27. Can I simplify this? Yes. Divide each of these by 3 and you get 5/9. Now I can plug those in to point slope form. And you can see here that, again, we changed the y's to c's and the x's to f. So we plug 5/9 in for my m. We plug in 50 for f sub 1 and we plug in 10 for c sub 1. Is there anything else we can simplify here? No. So this is the point slope form of the equation of the line going through these 2 points. Perfect. But it does say it wants the equation giving Celsius in terms of Fahrenheit, which means it wants C by itself on one side of the equation. So we're going to solve for C. How do we do that? Well, we distribute the 5/9 to the F and to the negative 50. 5/9 times F is 5/9 F, and then 5/9 times negative 50. Remember, negative 50 is the same thing as negative 50 over 1. So we multiply 50 times the 5 and then 9 times the 1. So you end up getting this fraction. Now, again, I want C by itself, so I need to get this minus 10 to the other side. That means I add 10 to both sides. Adding 10 to negative 250 over 9, it's a little tough. We need to give it a common denominator. So it would be 90 over 9. So if we add 90 over 9 here, we end up getting negative 160 over 9 as our y-intercept. Now we have Celsius in terms of Fahrenheit. Cool. You could have also picked the other point to be your f sub 1 and c sub 1, and you would have got the exact same thing. Again, my slope should have turned out the exact same, which it does. When I plug it in to point slope form, the 77 now is going to go in for f sub 1, the 25 is going to go in for c sub 1, and the 5/9 goes in for my m still. And now I have the point slope form just with the other point this time. These are the exact same thing, except I just picked 2 different points on the line. Now, if I wanted to distribute it and show you that they are, in fact, the same equation, I distribute the 5/9 to the f and the negative 77. Now, I want c by itself, so I'm going to add 25 to both sides. That's how I get the negative 160 over 9. Now, all I have to do is figure out what the Celsius temperature is when it's 59 degrees Fahrenheit. So, I'm going to take this and I can plug it in for f in any of these 4 equations. Now, here's the deal. I can use these guys, but look at these y-intercepts. I don't want to deal with that. So what I'm going to do instead is I'm going to use one of these 2. They're a lot easier to work with. So I'm going to plug in to this equation right here. I'm going to plug in 59 for my Fahrenheit. Boom. Now I simplify. What's 59 minus 50? That's 9. And what's 9 times 5/9? Well, 9 is the same thing as 9 over 1. So I multiply the 9 and the 5 together, the 1 and the 9 together. I get 49 over 9, which simplifies to 5. Now what I can do is I can get c by itself by adding 10 to both sides of the equation, and I get c is equal to 15. So we're not going to leave this as our answer, right? We have to answer the question. What is the Celsius temperature when it's 59 degrees Fahrenheit? Well, I got c is equal to 15, therefore it's 15 degrees Celsius when it's 59 degrees Fahrenheit. And again, I could have got this answer from this equation, and this equation. They're all the same line. They're all the same graph. They're all the same equation. They just look a little bit different.